The videos in this playlist would be concerned on one of the application of congruence, which is on the verification, on the validity of the divisibility test that we know of any integers ranging from divisibility of test 2 and so on and so forth. We know that there are some divisibility rules and tests that we follow in order for us to determine whether a certain integer is divisible by a certain smaller number. So before we could go to the verification process, as the next videos will be concerned with, we need to start with this preliminary background concepts so that it'd be easier for us to show the validity of the divisibility test, because we'll be using some of this as we go through. Okay, let's start with the idea of congruence. The first preliminary background concept is the idea of our linear congruence. We have here A is congruent to B modulo N. This means that if we look at this perspective, we can say that N divides the difference of A minus B. So whatever would be A minus B, and N, which is any integer, could divide that result. That means that A is congruent to B modulo N. This also means that B in this given expression is the remainder when A is divided by N. That's another perspective with this. Okay, B is the remainder. Now, this is the first background concept, because we need to really understand what does this A, B, and N represents. So we have here our N is our divisor, our A is an integer, and B is the remainder when that integer is divided by N. Or we could also use this, that N divides A minus B. The second background concept we need to use here is the law of power for congruence. Okay? For congruences, which means that if A is congruent to B modulo N, we can say that if we have an expression A raised to the power of M, any exponent, this is just still congruent to raising our remainder to the same exponent modulo N. Okay? So if we have here an expression of A to the power of M, meaning the integer is raised to any or an integer can be expressed as an exponentiation of smaller base A. We just say that the same exponent is, or the remainder will be raised to the same exponent. This means that if B is the remainder when A divides N, then we can say that B to the power of M is the remainder when A to the M is divided by N. So that would mean simply raise the remainder as well of the same exponent, and you will have the same congruence. The next one, okay, let me move down here. I still have a lot of spaces here. The next background concept is the idea that any integer n, okay, can be rewritten probably as this form. Okay, n could be rewritten as equal to this form. I'm gonna discuss this anyway, so let me just write this first. B to the power of n minus 1 plus dot 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 plus a sub 1b plus a sub 0. Any integer can be written like in this form. Specifically, okay, for base 10, using base 10, okay, we can say that an integer can be written as a sub m, this is the digit, times 10 to the power of m, plus the second digit times 10, so that's 10 now. 10 to the power of m minus 1, let me rewrite it, plus dot dot dot, plus a sub 2, 10 squared plus a sub 1 times 10 plus a sub 0 times 10 to the power of 0 is just simply 1. So any integer can be written with as this with base 10. Any example would be like this. Example, if we have 1492 as our n, this can be written as the first digit times 10 cubed plus the second digit times 10 squared plus the third digit times 10 plus the units digit times 10 to the power of 0, or just simply 1. Okay? So just like this will be our first digit, second digit, until here, and it will be our units digit here. And that's what we actually use. We have base 10 there. Another example is if we have 365,213. This can be written as, so you have 3 times 10 to the power of 5 plus 6 times 10 to the power of 4, the 10,000s, plus 5 times 10 cubed plus 2 times 10 squared plus 1 times 10 plus 3 times 10 to the power of 0 is just equal to 1. So any integer can be written like this. Take note, this is very important background concept before we proceed to the proving process. And the last background concept that I would like you to highlight, this is C, so D. The fourth one is n integer n is divisible by small letter n if and only if, okay, n is congruent to 0 modulo n. This means that 0 is the remainder when our integer n is divided by our small letter n. And if it's 0, take note that if the remainder is 0, that means the small letter n completely divides the larger integer capital N here. So these are the four concepts I would like you to review before we proceed to our proving or verification of the divisibility test. The first one is the simple understanding of A congruent to B modulo N, where B is the remainder. Take note of that because it's connected to B, that the remainder of A to the power of M is we simply raise the original B to the same power M. Okay? The third one is we can represent any number, any integer, specifically it's integer, any integer, okay, using base 10 in this manner, okay? Take note of that. And finally, we can say that our small, our big letter capital, our capital letter N is divisible by the small letter n if the remainder is 0, and in this form, n is congruent to 0 modulo n. So take note of this as we proceed to the first video on the divisibility test for 2. Thank you very much for watching.